This time we're going to discuss another application of the stack data structure, and this is on the algorithm to convert from infix to postfix expression. In this algorithm, we make use of only one stack, S, and top is the index of the top element. And we have here a special character which marks the end of the input infix string. So we add here or append that special character and the bottom of stack S. So say for example, this is our stack S. We also have that special character or symbol at the bottom of the stack. Again, before we start in the algorithm, we have to mark the end of the string with this special character and mark the bottom of the stack with this special character. Now you could actually use any special character. It should be a unique character that you are sure that it will never be used in any arithmetic expression. So it should not be a variable, or it should not be a letter or a digit, because letters and digit could appear as operands in the arithmetic expression. So it should be something else, not a letter, not a digit. It should be a special character. This precedence table is implemented as a function, this part here. So this user-defined function is actually an implementation of this precedence table. So this user-defined pred function accepts one parameter, which is the symbol that we get from the input infix string. The output of this function or this function will return an integer type value, which is this one here. So this is the input parameter to the function, and this part here is the possible returned value, which is type integer. So it tells us that for this special character, the precedence of that is 0. And for addition and subtraction, the precedence value is 1. And for multiplication and division, the precedence is 2. So as you can see here, that multiplication and division operators have higher precedence than addition and subtraction. And multiplication and division have the same priority, and also addition and subtraction have the same priority. And for operands, any operands, numbers or variables, the precedence value is 3. When you call the function pred and the input parameter is plus, this would return 1. If the input parameter to the function pred is division symbol, this function would return the value 2. Let's say the input infix expression string to this algorithm is this infix expression here. This is our infix expression string, which is the input to the algorithm. And we have here local variables. I initially set to -1 and top is 0. This is top equal to 0. The implementation of stack is like a one-dimensional array. This would be like your S0. Next element on top of this is S1. Next is S2. Next is S3. When we say here S index top is equal to that, this would be S0, right? Because top here is set to 0. So S0 is that special character. We have here S0 to be that symbol. That is how we put or assign the special character at the bottom of the stack. And this next car here is a function that gets the next symbol from the infix input and assign it to local variable next. The first value of next would be 5, right? And we have here a while loop starting from this open curly and up to that. And we have here an inner while loop inside the while loop. So we have nested while loop. The first or the outer while loop will continue to iterate as long as we have not yet reached the end of the infix string. So as long as next is not yet equal to that, we continue to iterate the outer while loop. So when will this becomes false? This will become false, or the outer while loop terminates when we reach this part in the input infix string. But this time at the start, we are here. Next is equal to 5, the first symbol, which is an operand. So this is true, right, on the first iteration. And so we get into this while loop body to execute the inner while loop. And pred next, what is pred next? It is pred 5, okay, is less than or equal to pred s top. S top is what? This is the special character or special symbol. What is the value of pred 5? 5 is an operand. It gives you 3. So this part here is equal to 3. The pred function returns 3 for input parameter 5, which is an operand. And pred, this special character, the bottom marker of the stack, returns to us 0. Pred stop is 0. So while 3 less than or equal to 0, this condition is false, right? And so this is not executed. We proceed here as push next. So we push the next symbol, which is 5, into the stack. So we have here 5. And then we get the next character from the input infix. The next character is plus. So this is now addition. And we get back to this condition that is true. So we get in here pred. What is next now? It is plus. Okay, and s top, this is now top. Top is now equal to 1. We increment top when every time we push a new element into the stack, we increment top. Again, every time you push a new element into the stack or add a new element into the stack, you increment top. So s top now, or s1, is equal to 5. This is pred 5. Pred plus is 1. And pred 5, 5 is an operand, it gives us 3. So 1 less than or equal to 3, the condition is true, right? Since that is true, we execute the inner while loop. Increment I, so I becomes 0. Okay, because we start with I equals -1. And then temp gets the element, the top element we pop from the stack. So we pop this, which is 5. Okay, we pop 5 out of the stack. And so top now becomes 0 again. So remember that every time you push, you increment top, and every time you pop, you decrement the top. So since we pop in here, we decrement top, so top becomes from 1, it becomes 0 again. So the value of temp in here is 5. And then rev pool is an array of characters, or it is a string. And say for example, rev pool is this string variable. I is 0, so rev pool I, this is index 0, index 1, index 2, and so on. In the string, rev pool 0, which is this first character here of the string, is set to that 5. And then we go back to this condition. Pred next is still plus, and the top now is the special character marker. So this is the special marker. The precedence of plus is 1, and for the special character it is 0. So we check the condition 1 less than or equal to 0, that is false, and so the inner while loop terminates. So it took only one iteration. And then after that, we push next, which is this plus symbol into the stack. So we have here now plus. And then we get the next symbol from the input infix, and that is now 2. So next is now equal to 2. And we go back to this part here. It's not the end of the string yet, so we get back into the inner while loop. Pred next is 2. So this is now next is 2, and top is now plus, right? So remember that the top, since we pushed plus a while ago, the value of top now is equal to 1. That's the current value of top when we push plus. And so going back here, pred next, which is pred 2, that gives us 3 because 2 is an operand. So this is 3. And the pred stop, that's plus is 1. So is 3 less than or equal 1? It is false. So the inner while loop is not executed. We jump into this part, which is to push 2 into the stack. So we have here 2. And top now is incremented. It becomes 2. And after that, we go back here. And after we push 2 into the stack, we get the next character, which is multiplication. So this time, the next symbol is multiplication. And it's not the end of the string yet. So we go back to execute the inner while loop. And this time, our next is asterisk. And S top is 2. So what is the precedence of asterisk or multiplication? It is 2. And what is the precedence of 2, an operand? It is 3. So 2 less than or equal to 3, that's true. Therefore, the body of the inner while loop is executed. We increment I now becomes, from 0, it now becomes 1. And then temp is the value that we pop out from the stack, which is the top element. And so we pop this 2. So top now is decremented. Top becomes 1, and currently the top element of the stack is plus. So 2 is the value of temp, and we append temp into the string variable reb pool at index 1, right? Because your I here is 1. So at index 1, this is 2. Then we go back to the condition. Our next is still the asterisk or multiplication operator, and the top now is plus, right? So we have already popped this out. So top is plus. So this is, and what is the pred of multiplication? It is 2. And for plus, it is 1. So 2 less than or equal to 1, that is false. Therefore, we don't execute the inner while loop body. And so we proceed to pushing the next symbol, which is asterisk, into the stack. So we have here asterisk or multiplication, and we increment top becomes 2. This is the current top, the multiplication operator symbol. And then we get the next symbol from the infix input. It is now 4, right? So the value of next now is the operand 4. And then we go back to this condition. It's not the end of the string yet. And so we get into the inner while loop. And next, this time is 4. And S top is asterisk. So what is the pred or precedence of operand 4? It is 3. And for asterisk, it is 2. 3 less than or equal to 2, that is false. So we don't execute the inner while loop body. So we jump into pushing next, which is 4, into the stack. So we have here 4, and the value of top now is equal to 3. So that is now the index of the top element 3. And the top element now is 4. And then we get the next symbol. It is minus. So this is now minus or subtraction. And it's not the end of the string yet. So we get into the inner while loop. Next is minus, and S top is 4. So minus, precedence of minus is 1. And the precedence of operand is 3. So 1 less than or equal to 3, that's true. And so we get into the while loop. Increment I now is from 1, it becomes 2. And we pop from the stack and assign it to temp, variable temp. What we pop is 4, right? So 4 is popped and top becomes 2 again. So the top element now is asterisk. The value of temp is 4. And then we append 4 into the string variable rev pool at index 2. So at index 2, we have here 4. And then we go back to this condition. Pred next less than or equal to what is now the top. The top is asterisk. And multiplication or asterisk, the precedence is 2. So this is now 2. And pred next or minus is 1. 1 less than or equal to 2. That's true. So we get into the body of the inner while loop again, executing it for the second time. So that's the second iteration. We increment I. I now becomes from 2. It now becomes 3. And we pop from the stack. We pop asterisk, this one, and top becomes 1 again. So this is removed. So this is asterisk. And then we append that symbol asterisk into the string variable rev pool at index 3. So at index 3, we have here asterisk. Then we go back to the condition because this is while loop. So pred next, it's still subtraction. And the top now is addition. So this is now plus. The current top element of the stack is this one here, plus. Okay, so that is plus. So pred of minus is 1, and pred of plus is also 1. 1 less than or equal to 1, that's true. So we execute this part again. Increment I now from 3, it becomes 4. And then we pop from the stack, and what we pop is the plus symbol, okay, because it is currently the top of the stack. So since we popped that out already, we remove that, and the value of top is decremented from 1, it becomes 0, and the new top element is now this special character. And then we append the value of temp, which is the character plus or addition, in the string variable rev pool at index 4. So at index 4, we have plus symbol. After that, we go back to the condition of the inner while loop. Next is minus, and the new top now is the special character, which is the bottom marker. Pred of minus is 1, and pred of the special character is 0. So this is 0, 1 less than or equal to 0. That gives us false, right? And so the inner while loop terminates, and we move to this part, which is to push next into the stack. So we have here minus, and we increment top. Top now becomes 1. Then we get the next symbol from the input infix. It is now 9, an operand. And we go back here. It's not the end of the string yet, so we get back into the inner while loop. The next value is 9, and top is minus. So pred 9, which is an operand, it gives us 3. The precedence of operand 9 is 3 from the table. And the precedence of minus is 1. So 3 less than or equal to 1, that is false. So this is not executed, and we jump to push the value of next into the stack. So this is now 9. And we increment top, it becomes 2, and we get the next symbol, which is division. And then it's not the end of the string yet, so we get back to the inner while loop. The value of next is division, and top is 9. Top of the stack is 9. And the pred of precedence of division is 2. And the precedence of the operand is 3. So 2 less than or equal to 3, that is true. And so we execute the inner while loop body. We increment I from 4 becomes 5, right? So I now is 5, and then we pop from the stack, we pop out 9, so top is decremented, top becomes 1 again. The new top now is minus, and so temp is equal to 9, and we append 9, operand 9, into the string variable rev pool at index 5. So at index 5, we have here 9. And then we go back to the condition. Next is still division, and the top now is minus, right? The top element is minus. And the pred of minus or subtraction is 1, and the pred of division is 2. 2 less than or equal to 1, that is false, and so the inner while loop terminates, and we proceed to push the symbol next into the stack. So we have here division, and once again we increment top. Top now becomes 2. So top is equal to 2, and the current top element is division. Then we get the next character. The next character is 3. It's not the end of the string yet, so we get inside this part the inner while loop again. Next is 3, and top is division. The top of the stack is division. The pred of operand 3 is 3, and the pred of division is 2. 3 less than or equal to 2, that's false. So we jump into here because we skip this part because the condition is false. We push next 3 into the stack. So we have here 3 as the new top, and then increment top. Top now is 3. And then get the next symbol. The next symbol is now the end of string marker, which is the special character. So we are currently here now. So next symbol is the string marker. So we have reached already the end of the string. So this is now, so the condition of the outer while loop is now false. And so the outer while loop terminates and we jump into this part, the next while loop. The condition is while stop is not equal to that, the special marker, the current top is 3. So since that is not yet the special character, the top of the stack, okay, this is true. So we execute this, increment I currently is 5, so I now becomes 6. And we pop from the stack, we pop 3, so top now is equal to 2. Okay, so that is removed. So this is 3, and we append 3 to the string variable rev pool at index 6. So at index 6, this is 3. Then stop is division. So it's not yet the special character. Therefore, this is true. Increment I becomes 7, right? And we pop from the stack, we pop out division, so we remove division, and the top is decremented, it becomes 1. Okay, so we remove that, and this is now division symbol. And we append this symbol division at the string variable rev pool at index 7. So this is division. Then we go back to the condition. The top is not yet the special character, it is minus, so this is true. Increment I again, I becomes 8, and pop the top element of the stack, it is now minus. Okay, so we pop this out, top becomes 0, so temp is minus. We remove this from the stack, so the new top now is the special character. And then the temp, which is the one we popped from the stack, recently popped out from the stack, the minus, we append that to rev pool string variable at index 8. So at index 8, we have here minus. Then we go back to the condition. Stop now is the special character. So the condition here is now false, right? So since that is false already, we don't execute the while loop anymore, and that's the end of the algorithm. At the end of the algorithm, the value of the string variable rev pool is the string 524 times plus 93 divide minus, which is the postfix form of the input infix. Let's try to convert this infix into postfix. This would now be 24 times, and this is 93 divide, and this is executed first before minus, so this would now be 524 times plus. So this is left operand, right operand of the operator plus, and then this is the left operand of minus, and the right operand of minus is that. So we have here 93 divide, the right operand, and then the subtraction operator. So the postfix now equivalent of the input infix is this, okay, which is what we got here. Okay, from the algorithm, 524 times plus 93 divide and then minus. Now, we name this string variable rev pool because reverse Polish is another name for postfix. So this is the algorithm to convert from infix expression to postfix expression.